All right, question 16. Just let me make sure I've got my microphone on. Yep. Question 16. So we're expanding these. Don't forget, if I've got a plus b all squared, then that comes out as the first thing squared plus 2 times the first thing times the second thing plus the second thing squared. So this is going to be x to the half squared plus 2 times x to the half times x to the negative half plus x to the negative half squared. So this is x to the half times 2 plus 2x to the half plus negative a half plus x to the negative a half times 2, which gives us half times 2, 1, x to the 0, negative 1. So we've got x plus 2 plus x to the negative 1. They've asked for it in index form, so we leave it as x to the negative 1, not 1 on x. Okay, now this one we're going to have x to the 5 on 2 squared. Take 2 times x to the 5 on 2 times x to the negative 5 on 2 plus x to the negative 5 on 2 squared, which gives us x to the 5 on 2 times 2, take 2x to the 5 on 2 plus negative 5 on 2 plus x to the negative 5 on 2 times 2, multiply x to the 5. This will be x to the 0, x to the negative 5. So we've got x to the 5, take 2, plus x to the negative 5. They weren't bad at all. This one we're going to do the same thing. Oh, we're going to need so much more space. Okay. So here we've got x squared plus 2 times x times 5x to the minus 1 plus 5x to the minus 1 squared. Gives me x squared plus 2 times 5 is 10, x to the 0, because it's 1 plus negative 1, plus 25x to the minus 2. Do I need to write x to the 0? No. This one we've got 3x to the half squared. Take 2 times 3x to the half times 2x to the negative 2x to the negative half plus 2x to the negative half squared. Gives me 3 squared, x to the half times 2 is 1. Take 2 times 3 times 2, 12, x to the half plus negative half, 0, plus 2 squared, 4. Sorry, I know I should write 2 squared. X to the negative half times 2 is negative 1, which gives me 9x, take 12, plus 4x to the negative 1. Answering without using negative indices. So this one, x squared plus 10 plus 25 on x squared. This one, 9x, take 12, plus 4 on x. Fairly simple. Okay. So we've got, for question A, I'm not going to explain how this works. You know equating indices it works, like it's the same thing, because this is, then fine, I will explain. So this is 3 to the 3x take 1 equals 3 squared, so 3x take 1 equals 2. Like that's all you need to write. So this is 125 to the x equals 1/5. I'm going to make them both base 5. So 125 is 5 cubed to the x, and this is 5 to the minus 1. So we've got 5 to the 3x equals 5 to the minus 1, so 3x equals negative 1. X equals negative 1/3. Question C. We've got, I swear we've done these, equals 1/4. So this is 2 cubed to the x, and this is 2 to the minus 2. If you can't recognise y, then that's the same as 2 squared to the minus 1. So this is 2 to the 3x equals 2 to the minus 2. So 3x equals negative 2. So x equals negative 2 thirds. And E, we've got, ooh, I like this. We've got 8 to the x plus 1. I'm just going to write the question. 2 times 4 to the x. Take 1. 8 is 2 cubed to the x plus 1. 2 to the 1 times, and this is 2 squared to the x. Take 1. So this is 2 to the 3 times x plus 1 equals 2 to the 1 times 2 to the 2 times x. Take 1. That's a take, not a plus. So we've got 2 to the 3x plus 3 equals 2 to the 1 times 2 to the 2x. Take 2. So now, oh no, not yet. We've got 2 to the 3x plus 3. Now we've got to add these ones because it's timesed. So we've got 2 to the 1 plus 2x, take 2, which means 3x plus 3 equals, now what is 1 plus 2x, take 2? 2x, take 1. Get the x's over to the left. So we're going to minus 2x to both sides. Get the 3's over to the right. We're going to minus 3 to both sides. So we've got 1x equals negative 1, take 3, negative 4. Question 21, penultimate question. And they've told us that x equals 2 to the 1/3, plus 4 to the 1/3. So x cubed, we're trying to show what x cubed, we're hoping to show that it's going to come out as this. But we're going to have to go through the process. So x cubed is 2 to the 1/3 plus 4 to the 1/3, cubed. Now don't forget when we're expanding cubes, a plus b cubed. Just from Pascal's triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. We've got 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. Okay, which means we've got 2 to the 1/3 cubed plus 3 times 2 to the 1/3 squared times 4 to the 1/3 plus 3 times 2 to the 1/3 times 4 to the 1/3 squared plus 4 to the 1/3 cubed. Okay, which gives me 2 to the 1/3 times 3 is 1 plus 3 times 2 to the 2/3 times 4 to the 1/3. Actually, I'm going to leave this as 2 to the 1/3 squared plus 3. Actually, I'm going to deal with these ones, but I'm going to finish off by plus 4 to the 1/3 times 3 is 1. Now with these ones, I'm going to factorize. This is the same as 1 plus x. This is the same as 3. So the common factors, I'm taking out common factors. My common factors are 3, 2 to the 3rd, and 4 to the 3rd. When I take them out the front, I end up with 2 3rds left over from the first term because that was squared. 4 3rds left over from the second one because that was squared. So here, now let's group our like terms. 2 to the 1 plus 4 to the 1, 6. Now, this is 3 times 2 to the 3rd times, now 4 is 2 squared to the 3rd. And this thing here is the same as x. Yeah? So I'm going to replace it with x. Mostly because the answer has x in it. So I've got 6 plus, now this is 3 times 2 to the 3rd times 2 to the 2 thirds times x. So I've got 6 plus, now this is 3 times 2 to the 1/3 plus 2 thirds, 1. So this is 6 plus 6x, so this is 6 outside of 1 plus x. I like that question. Okay. C is going to be a bit of a nightmare fractions wise. Love it. So we've got, I'm going to start from the left and see if I can get the right. We've got PQ minus 1, take P minus 1Q over P squared Q minus 2, take P to the minus 2Q squared. So this is like writing P on Q minus Q on P over P squared on Q squared minus Q squared on P squared. I'm going to cross multiply with the top and the bottom. So the top becomes P times P, P squared. I'm going to have to leave myself a line so I can read it. So I've got P squared minus Q times Q, Q squared, over P times Q, PQ. That whole thing is going to be over, just want it to be easy to read. Down here I'm going to cross multiply as well. So I've got P squared times P squared, P to the 4. I can't write 4 is small. Same with the Q's, I'm going to have Q to the 4 over P squared Q squared. Now let's not forget that this is the same as the first divided by the second. So the first whole fraction divided by the second whole fraction, yeah? So this is the same as P squared minus Q squared over PQ divided by P to the 4 minus Q to the 4 over P squared Q squared. Dividing by a fraction, we need to times by its reciprocal. So it's KFC, key flip change. P squared minus Q squared over PQ times P squared Q squared over P to the 4 minus Q to the 4. So we're going to be able to simplify P and Q. But with the rest, we're going to have to do some factorising before we can cancel out. I want you to now remember that A squared take B squared is A take B, A plus B. A to the 4 minus B to the 4 is the same as A squared take B squared, A squared plus B squared. Because it's like A squared squared, yeah? So this one is going to end up being P take Q, P P plus Q. It's just over 1 times PQ over P squared take Q squared. Hey, if I was already going to get P squared take Q squared, I should have just left this as P squared take Q squared. P squared plus Q squared. And that gives me, this whole thing cancels out with this whole thing. And I get 1 times PQ over 1 times P squared plus Q squared. Which I think is the answer we wanted. Yes! Ugh, I love doing something really complicated and not really knowing where I'm going to go and then getting there. Finally, if we've got 11 to the 1/3 and we're trying to show that it's less than 5 to the 1/2, and they're suggesting taking 6 powers of both sides. And that's mostly because 3 times 2 is 6. So let's do 11 to the 1/3 to the 6. If we do it to both sides, we don't have to change that sign. To the 6. So we've got 11 to the 1/3 times 6 is squared. 5 to the 1/2 times 6 is cubed. 11 squared is 121. 5 cubed is 125. True. So let's do A. We're going to do the same here. We've got 3 to the 1/3 less than 2 to the 1/2. 3 times 2 is 6, so we're going to raise them both to 6. So we've got 3 to the 1/3 to the 6 is less than 2 to the 1/2 to the 6, which means 3 to the 1/3 times 6 is 2. 2 to the 1/2 times 6 is 3. Did I do this right? Did I write that down correctly? So this is saying 9 is less than 8. No. So that means 3 to the 1/3 is actually greater than 2 to the 1/2. Oh, it's just a way to double check. Okay, and let's do C. So now they're saying 7 to the 3 on 2. I'm going to see if it's less than 20. And this is 20 to the 1. 1 times 2 is 2. So I'm going to square both of them. So I've got 7 to the 3 on 2 squared less than 20 squared. So 3 on 2 times 2. So I've got 7 to the 3 less than 20 squared, 400. 7 to the 3, 7 times 7 is 49, times 7 is 343. So 343 is less than 400. So we know that 7 to the 3 on 2 is less than 20. So this is just a way to double check which one's smaller. And that's it, that's the end of